Hey guys, today we're going to be taking a look at this Math Olympiad question, which is for n is greater than or equal to 2, let k of n be the product of 5 times 10 times 17 times 26, all the way to n squared plus 1, and let Sn equal 1 minus 1 over 2 to the power 4 times 1 minus 1 over 3 to the power 4, all the way to 1 minus 1 over n to the power 4. And the question is, they're asking us to find what is Sn over Kn. So we have Sn over here, and they said Kn was this over here. Now we have to find Sn over Kn. Pause the video right now and see if you can solve this problem. Alright, so this was a bit tricky at first. Even myself, I didn't know how to solve this at first. But in the end, it's mainly just basic algebra with a little bit of factorials. Nothing big, nothing calculus related, just algebra. So I'm sure we've all known the formula of a squared minus b squared and how it's equal to a plus b, a minus b. So let's take Sn. So taking Sn, we're going to leave Kn for now. Let's just focus on simplifying Sn. Sn, you can see it is somewhat in the form of this formula right here. Why? Well, a squared is just going to be 1 squared, and b squared will vary. So this one would be, so in this case, b would be 1 over 2 squared. In this case, b would be 1 over 3 squared. In this case, b would be 1 over n squared. So we can rewrite this as, let me move this over here. We can rewrite Sn as 1 minus 1 over 2 squared times 1 plus 1 over 2 squared. So this whole thing that I just wrote is this thing right over here. I just rewrote it using this formula. All right, next, let's write this one over here. So that's going to be times 1 minus 1 over 3 squared times 1 plus 1 over 3 squared. All right, then we have the dot, 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 and we'll do that for the last term, which will be 1 plus 1 over n to n squared times 1 minus 1 over n squared. Alright, so now we have simplified this using this difference of squares formula. In addition, we can further simplify this, so let's just leave this as it is, and you will see why in a moment. So let's just leave that as it is. It is true we can simplify this, but then we'd be going a little bit off track. So instead, let's simplify this, the ones with the plus. And you will see why in a second. It is because once you simplify this, you would get 2 squared plus 1 over 2 squared. So that's basically 5 over 2 squared. And you will see that there's a 5 over here in Sn, but in Kn, we also have a 5, which is the first term. However, if we did this subtraction, if we simplified this, you'd get 3 over 2 squared, and that's kind of pointless because we can't make use of Kn in that case. So that's why we expanded only the terms or the stuff in the parentheses with the plus sign, so we can get something in terms of Kn. So now we have 5 over 2 squared. Once again, we're going to leave that minus, this term with the minus as it is, because if we simplify it, once again, we won't get anything that relates to Kn. So 1 minus 1 over 3 squared. Now let's simplify this. You get 3 squared plus 1 over 3 squared, which is 10 to the over 3 squared. And once again, there we go. We have a 10 in Kn and we have a 10 in Sn. Now we keep doing that. Once again, leave the 1. Oh, now we do the plus over here. My bad, I should have written it the other way. But now if we simplify this, we get n squared plus 1 over n squared. And what do you know? This term in Sn is also the same as this term in Kn. So we're getting somewhere. And then we leave the minus 1 as it is. 1 minus 1 over n squared. Alright, so this is Sn. So I think we are pretty much done with solving for Sn, because once again, we don't really want to simplify this because it would defeat the whole purpose. It would just make things a lot more confusing. So now let's just get into it. Let's just divide by Kn. So if we divide by Kn, dividing Sn over Kn. So this was the first step. This is our second step. Now we are going to do that. Well, kn, let me just put kn. Let me take that. All right, so this is kn as shown in the example. So right now I'm just going to hide the question because we don't really need that right now. We already have all the information here. This is Sn and this is Kn. Now let's just start dividing. So if we divide, we get Sn equals this whole thing. So I'm just going to copy this whole thing. All right, we get Sn over Kn, which is 5 times 10 times 17 times 26 times ... n squared plus 1. Now we can start simplifying. Well, this is Sn over Kn, excuse me. Now we can start simplifying. We see that this 5 and this 5 cancel out. We see that this 10 and this 10 cancel out. The 17 will also cancel out if we wrote one more term. The 26 would also cancel out if we wrote another term. And eventually this n squared plus 1 and n squared plus 1 will cancel out. So we've already seen that a lot of things, a lot of terms, a lot of numbers are already canceling out. Now let us simply rewrite this. So we're going to get 1 minus 1 over 2 squared times 1 over 2 squared from over here. 1 minus 1 over 3 squared times 1 over 3 squared, ... 1 over n squared times 1 minus 1 over n squared. There we go. All right, so this is Sn over Kn. In order to simplify this a little bit more, we can also introduce factorials, because what we're going to see over here is that we're going to have 2 squared, we're going to have 3 squared, the next term will be 4 squared, and it'll go all the way up to n squared. So we can rewrite this. We could say that 1 over n factorial squared. Now, how can we write all of these terms as this? Well, I will show you. So this one is basically saying 1 over, actually let's take all of these. So this is saying 2 times 2 because of 2 squared. This is saying 3 times 3 because of that 3 squared. After that it's going to be 4 times 4, then 5 times 5, all the way to, can you guess? That's right, n times n. And over here, of course, it'll also be a 1 times 1, but that doesn't really change the value, but we're going to put in there anyway. Now, let's take this term, this, and this. You see they're all being multiplied. And from that, what do we know that 1 times 2 times 3 times 4 times 5 all the way to n is? Well, that's right. It's just n factorial. But remember, we only counted for half of the terms because we still have these terms we still need to count. And once again, this is the exact same thing as previously. 1 times 2 times 3 times 4 times 5 all the way to n. Well, that's also n factorial. What's n factorial times n factorial? Well, that's just n factorial squared. So that is how we got this n factorial squared for these terms over here. All right, now that we have established how we got the 1 over n factorial squared, we can just rewrite everything else as it is. So 1 over 2 squared times 1 minus 1 over 3 squared, ... 1 minus 1 over n squared. All right, now we can start to simplify a little bit, because the only things we can simplify at this point are this, basically whatever's in the parentheses. So let me just take up a new page. All right, so in case you forgot, this is Sn over Kn. So eventually, if we solve the right side, we would get the answer to the question, which is asking us to find Sn over Kn. Now let's start to simplify the stuff in the parentheses. So now let's just use difference of squares once again. Let's keep that n factorial squared the same. Difference of squares, 1 plus 1 over 2 times 1 minus 1 over 2. That is this term here. Focusing on this term, we have 1 plus 1 over 3 times 1 minus 1 over 3, ... And finally, this term will be 1 plus 1 over n times 1 minus 1 over n. 1 minus 1 over n. All right, so now, seems that we have simplified. Let's try simplifying each one of these, because now we definitely know we cannot use difference of squares over here. So, simplifying the first parentheses, we get, let's just rewrite this. Simplifying the first parentheses, we get 3 over 2. And now what I think we should do, we should start to introduce more terms, because we see at this point we can cancel out a lot of terms, but we want to know what terms we're going to be left with, and the terms that we are going to be left with will be our Sn over Kn, aka our final answer. So let's actually delete this whole row and rewrite this row like this. 1 over n factorial squared times 1 plus 1 over 2, 1 minus 1 over 2, 1 plus 1 over 3, 1 minus 1 over 3, 1 plus 1 over 4, 1 minus 1 over 4, dot, 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 1 plus 1 over n minus 1, and then 1 minus 1 over n minus 1, times 1 plus 1 over n, 1 minus 1 over n. So what have I done here? Well, it's a lot to get a hold of, but let me go step by step. So up till here, it was all the same as this line, right? But over here, I started to notice a pattern. It was increasing. This value was increasing every second parentheses. So therefore, that's exactly what I did. I continued the trend. So over here it would be 4. The next one would be 5 in the denominator. And the next one would be 6. Now I did the same thing going backwards. We are already familiar with this part because this part aligns with this part pretty well. But what about this? Well, I know that the term before n is going to be n minus 1. Even though n minus 1 is not a concrete term like 2, 3, or even like 1.7, it still shows that it is 1 less than this n, which could be any number. Which is why I put n minus 1 in here and in here to get n minus 1. And this still follows the same trend as over here because as we see, we are increasing 2, 2, 3, 3, 4, 4, n minus 1, n minus 1. And then one more term that is bigger than n minus 1 will obviously be n. So now that we have added more terms, it should be easier to see what things are going to be canceled out and what things are going to be left. So let's start simplifying once again. This is 3 over 2, 1/2. So I'm just going to rewrite this in a better format so you guys can see. I'm just going to rewrite it as 1 over 2 times 3 over 2, 2 over 3 times 4 over 3, 3 over 4 times 5 over 4, dot, dot, plus 1 over n. This way it's kind of easier to see what will cancel out and what will not cancel out, but of course you could just start canceling out from this stuff right over here. Now let's see what will cancel out. We see that this 3 and this 3 cancel out. We see that this 2 and this 2 cancel out. This 3 and this 3 cancel out. This 4 and this 4 cancel out. And as we continue, this 4 is probably going to cancel out with whatever terms over here. That 5 will also cancel out. Now, let's start to move over here. So overall, in the middle, almost everything will cancel out. Now let's see what will be left in the last few terms. That's why I wrote n minus 1 and n minus 1. I did not just take the last term. I took the second to last term as well so we can see what things cancel out much easier. That's a trick you should always do when solving these problems. Don't just write the last term. Always write maybe the second to last or even the third to the last if you want to be sure which terms are actually canceling. But for time purposes, I just wrote the second to last term. But of course, you could write the third to last term, in which case you would just replace n by n minus 2 because n is the last term, n minus 1 is the second to last term, and n minus 2 is the third to last term. And that trajectory keeps going on until you reach, well, like the first term. Now let's start simplifying. We see that this n minus 1 and this n minus 1 get canceled out. This n and this n get canceled out. And eventually, this n minus 1 will cancel out with something here. This n minus 2 will cancel out with something here. All right? Now, let's see what we are left with. We are left with this term, and this term. All other terms have been canceled out. Let's rewrite that. N factorial squared times 1 over 2 times n plus 1 over n. And that is our final answer.